Like when you upgrade your smartphone, the entire experience is just instantly faster.
Oh, yeah.
It's sleeker. It's infinitely more capable. There's this definitive before and an after.
Right. You feel the upgrade immediately.
Exactly. But when we look at the current state of tokenized finance, we find that attempting to upgrade the global financial system actually feels like going backward.
Yeah, it really might.
We've been sold this vision of, a frictionless, instantaneous digital future. Yet actually trying to move tokenized assets at scale feels incredibly clunky.
It's a completely disjointed reality, honestly. The fundamental tension here is between that promise of instantaneous global finance and the harsh reality of systemic bottlenecks.
Right.
The financial engineering is moving at breakneck speed. I mean, truly unprecedented. But the physical and digital rails supporting it, they're buckling.
Welcome to this deep dive into the absolute heart of tokenized finance. Today, we're examining this widening gap between fast-paced innovation and really slow-moving infrastructure. Our mission is to answer exactly why the infrastructure lags so far behind, and more importantly, what happens when this entire global system just, hits its absolute scalability limit.
Which it is absolutely on track to do.
Yeah. And for you listening, you already know the promise of blockchain. You know what tokenization is supposed to do. Today is about understanding the mechanical reality of why it still feels so frustrating to actually execute.
Exactly.
Okay, let's unpack this. What exactly is the math behind this core paradox?
Well, the paradox is rooted in these entirely different trajectories of progress. We're basically looking at a scenario where financial innovation is practically sprinting on an exponential curve. While infrastructure development is merely jogging on a linear one.
I see.
Think about the rate of tokenization right now. We have massive institutional capital onboarding. Complex real-world assets like treasuries and private credit are moving on-chain.
Right, the user demand is just exploding.
Exactly. But the foundational rails, so the blockchains, the settlement layers, the compliance frameworks, they're straining because they compound much, much slower.
Yeah, that mismatch in development cycles makes total sense. A team of really solid developers can write, audit, and ship an entirely new smart contract model for tokenization in what? A matter of weeks?
Yeah, weeks, sometimes days. And an institution can package and deploy a new digital asset product in maybe a few months.
Right. But actually standing up a globally synchronized, highly secure blockchain or overhauling an international settlement system.
That takes years. Years of brutal sequential development.
It's like trying to run a high-speed bullet train on 19th century wooden tracks.
That is a great way to put it.
You can manufacture the absolute fastest, most aerodynamic train in your facility, but the second you put it on those old wooden rails, it either crawls or the sheer velocity shakes the whole thing apart.
Yeah, it just shatters. And the exponential curve of innovation is constantly dumping, exponentially more assets and vastly more complex smart contract interactions onto these linear systems.
Right.
Systems that were simply not architected to handle this specific type of load.
But I have to wonder, is this friction really fatal? We talk about friction as this massive existential threat, but isn't it just like a temporary annoyance while the tech matures?
Yeah.
Why does a clunky user experience actually threaten the broader institutional adoption of tokenized finance?
If we connect this to the bigger picture, friction at this scale isn't just an annoyance. It is a hard ceiling on market viability.
A hard ceiling, wow.
Yeah, because institutional adoption requires absolute determinism. When demand explodes faster than the computational limits of a network, that friction translates directly into field transactions.
Which institutions hate.
Exactly. You get wildly unpredictable gas fees, and ultimately you lose trust. If a massive asset manager cannot guarantee the instantaneous, safe transfer of, say, $50 million in tokenized treasuries.
Because the underlying infrastructure is congested.
Right. They won't use it. They will retreat to the legacy systems they know. The friction dictates the absolute limit of the innovation.
So if the infrastructure is the ceiling, I guess we have to look directly at the foundation of the tracks themselves, the base layer blockchains. Because the instinct for most people is to just demand a better network, right? Why hasn't the market naturally coalesced around one perfect chain capable of handling the entire global load?
Because current blockchain architecture is governed by severe technological trade-offs. The ecosystem is currently trapped in a zero-sum reality.
Zero-sum meaning?
Meaning that optimizing for one metric inherently degrades another metric. Tokenized markets at an institutional scale require 5 specific elements to function simultaneously.
Okay, let's hear them.
You need massive throughput, near zero latency, absolute finality, low computational cost, and unshakable reliability.
And when you look at the landscape, it's pretty obvious nobody has solved that puzzle completely.
Not even close.
I mean, we all know Ethereum has the battle-tested security and reliability, but it fundamentally chokes on throughput and cost.
Right. And then you have Solana, which pushes the absolute limits of latency and throughput, but historically, achieving that speed has occasionally compromised network stability.
Yeah, we've seen those outages. And even when you look at application-specific chains, I mean, they offer ultimate customizability, but they trap you in an isolated environment.
And that isolation is the defining problem here. No single base layer currently balances all 5 of those requirements perfectly.
But wait, let me jump in here. Didn't Layer 2 scaling solutions already solve this?
What?
Because the entire premise of rolling up transactions and executing them off the main Ethereum chain was to drop costs and boost throughput.
Sure.
If an L2 gives you the speed and the low fees, why isn't that enough for a seamless user experience?
It comes down to the technological mechanism behind that scaling. When you build a Layer 2 rollup, you're fundamentally creating a separate asynchronous state machine.
A separate state machine.
Okay. Yeah. So yes, execution is cheap and lightning fast locally within that specific Layer 2 silo. But if a trader wants to execute an atomic arbitrage between an asset on Layer 2A and Layer 2B...
They can't.
Exactly. They can't. The global composability is broken.
Yeah.
Moving assets between these environments requires navigating complex bridging contracts.
Yeah, right.
You're paying main chain gas fees for state transitions and waiting for these asynchronous finality times.
So you optimize local execution, but you shatter the unified liquidity and seamless experience that institutional finance actually relies on.
Precisely.
Okay, so we have a fragmented base layer landscape built on zero-sum compromises. But let's play make-believe for a second.
Okay.
Imagine tomorrow, some development team drops the ultimate blockchain. It processes 1 million transactions a second, costs fractions of a cent, settles instantly, and never goes down.
The dream scenario.
Right. Even with that theoretical God chain, wouldn't we still slam into a massive wall?
We absolutely would.
Yeah.
Because a blockchain doesn't exist in a vacuum. It is deeply tethered to the traditional world.
Yes.
This is what we call the invisible bottleneck. The distributed ledger might operate at the speed of light, but the fiat systems, the custodians, and the regulatory frameworks that it has an interface with...
The real-world stuff.
Yeah, the stuff needed to actually settle real-world value. That is moving at a glacial pace.
Here's where it gets really interesting. Because the true bottleneck isn't the cryptography at all. It's the real-world settlement.
Yep.
It's like having a dedicated gigabit fiber optic line directly to your house. But the specific database you need to access is hosted on a dial-up server in a basement that automatically unplugs at 5:00 p.m. on Fridays.
That analogy hits the mark perfectly. Your unlimited bandwidth means absolutely nothing if the destination cannot keep up.
Right.
When we look at the mechanics of real-world settlement, these friction points are literally everywhere. Take institutional custodians, for example.
Okay.
Interacting with legacy banking APIs and internal risk management software is really expensive. It's computationally heavy. So custodians rarely process transactions instantaneously.
What do they do instead?
They batch them. Your lightning-fast, sub-second blockchain transfer gets parked in a digital holding pen. It just sits there until the custodian's internal software is ready to move a massive batch of transactions all at once.
And it gets so much worse when fiat currency is involved. Because blockchains are 247, 365-day continuous global markets. Traditional banking operates on business hours. They observe weekends. They observe like obscure banking holidays.
Exactly. So if you're trying to settle a tokenized private credit deal against a fiat wire transfer, your highly programmable digital asset is suddenly forced to sit dormant all weekend.
Just waiting for the physical doors of a bank to open on Monday morning.
Right. It creates a severe duration mismatch. And then you add the inherent latency of cross-chain messaging when complex smart contracts need to communicate across disparate networks.
Oh, wow.
And suddenly you have a 24-hour digital ecosystem artificially constrained by a 9-to-5 analog reality. The velocity of the tokenized asset is entirely anchored to legacy operational procedures.
It fundamentally breaks the illusion of instantaneous finance.
It really does.
But the friction isn't just caused by bankers' hours or legacy APIs. The core issue is the rules of the road.
Right.
You cannot have frictionless movement of institutional value without rigorously proving who is moving what. And that brings us to the scalability wall of identity and compliance.
This is perhaps the most difficult hurdle to clear, because you're basically forcing programmable money to abide by analog laws.
Yeah.
The existing frameworks for Know Your Customer, or KYC, and anti-money laundering, AML, they were architected entirely around the traditional banking model.
Where a few central entities monitor a manageable flow of high-value transactions.
Exactly. They were completely unprepared for an environment where millions of individual micro-investors and autonomous smart contracts are moving fractions of assets across highly decentralized global networks simultaneously.
But let me push back on that for a second. Compliance isn't optional, right? Stopping illicit finance is critical.
Absolutely.
We obviously want bad actors kept out of the system. So if the goal is securing the financial network, why does it matter if compliance slows things down a bit? How do we maintain that rigorous security without completely killing the velocity of tokenized markets?
This raises an important question, and it is the central debate in digital finance today. The issue isn't the existence of compliance.
Okay.
It is the mechanism of how it's currently enforced.
Yeah.
Right now, compliance acts as a massive scalability wall, because it relies on deeply fragmented identity systems and legacy paperwork applied retroactively to digital assets.
So it's the application that's flawed.
Right. Think about it. If a protocol routes a trade through an automated liquidity tool, how does a legacy AML framework handle the fact that the counterparty is a piece of code, not a person?
It doesn't.
Exactly. It doesn't.
Because when a transaction triggers an automated flag in the legacy system, it gets routed to a human compliance officer for manual review.
Yes, a human in the loop.
And if you take that human-in-the-loop process and apply it to a global blockchain processing tens of thousands of transactions a second, the entire network just grinds to an absolute halt.
Completely. And you also have the friction of users having to prove their identity from scratch across a dozen different isolated platforms.
Alas.
Plus, you're navigating jurisdictional conflicts where different countries have wildly different regulatory tracking requirements for the exact same digital asset.
It's a completely unsustainable model.
It is. The goal of the industry shouldn't be to bypass compliance, but to modernize the actual mechanism of it so that it moves at the native velocity of the network. Right now, it's just an anchor.
So let's synthesize this nightmare scenario we are currently looking at.
Let's do it.
We have a base layer defined by zero-sum architectural trade-offs and fragmented layer 2 states.
Yep.
We have a real-world settlement layer bottlenecked by 9-to-5 fiat banking integration. And we have a highly manual, human-dependent compliance framework struggling to govern autonomous smart contracts.
It's a mess.
What actually happens when you force all of these fundamentally incompatible puzzle pieces to interact?
You end up with a devastating interoperability crisis. Because these systems cannot communicate natively, the industry has relied on primitive workarounds.
You're talking about the bridges.
Specifically, cross-chain bridges and rudimentary messaging layers.
And we all know how vulnerable those are. But let's dig into why they fail so spectacularly. When a user tries to move an asset from one chain to another using a standard lock and mint bridge,
they aren't actually moving the asset.
Right. They are locking their original asset in a smart contract on chain A and minting a synthetic representation of it on chain B.
Exactly. And that mechanism creates a massive, centralized honeypot of locked collateral.
Just waiting to be attacked.
Right. Hackers don't attack the blockchains themselves. They attack the vulnerable third-party bridging contracts.
Because that's where the money sits.
Yep. And because these bridges are structural security risks, and because cross-chain messaging layers constantly suffer from congestion and misaligned technical standards, institutions just refuse to use them at scale.
So what does this all mean? It means liquidity actively isolates itself. You end up with deep pools of capital trapped on Ethereum, entirely separate from the liquidity on Solana.
Or isolated within specific layer 2 ecosystems.
Yeah. To make this concrete, imagine if the early internet was built with this architecture. It would be like a Gmail user being physically unable to send an email to an Outlook user.
Oh.
Unless they hired a highly suspect independent courier to physically carry the message across a digital bridge that has like a 20% chance of collapsing and destroying the message entirely.
You wouldn't use it. It defeats the fundamental premise of unified network.
Exactly.
Tokenization promised borderless, highly composable global liquidity. But as long as assets are forced to rely on these vulnerable third-party contracts just to navigate the ecosystem, the infrastructure will continuously fail the innovation test.
Okay, so we've thoroughly diagnosed the systemic bottlenecks. from isolated state machines at the base layer to the human-in-the-loop compliance traps. But how does this actually get fixed?
Well, the analysis doesn't just outline the impending scalability wall. It maps out exactly what the next era of infrastructure has to look like to support this bullet train.
Okay, let's hear the blueprint.
It requires a systemic architectural upgrade across 5 very specific domains. We need to move from incremental improvements to foundational overhauls.
Number 1.
First, throughput. We aren't talking about optimizing a chain to jump from 1,000 to 5,000 transactions per second.
That's not enough.
No. The infrastructure must achieve upwards of 100,000 TPS through mechanisms like parallel execution environments and dedicated data availability layers to actually handle global institutional volume.
Okay. Second is the finality problem, right? Waiting minutes for probabilistic finality is a non-starter for high-frequency trading and institutional arbitrage.
Absolutely. The next generation has to deliver single-slot, deterministic finality measured in sub-seconds. The transaction is initiated, and it is instantly cryptographically irreversible.
Third is solving the identity fragmentation.
Right. The industry must adopt unified, zero-knowledge identity frameworks.
So instead of repeating KYC checks endlessly.
Exactly. A user proves their identity once, generating a cryptographic proof. That proof becomes a portable credential that travels with their wallet across any chain.
Verifying their compliance without exposing their underlying personal data, that's huge.
Which ties directly into the 4th requirement, automating the compliance itself.
Right.
We have to abandon the legacy model of manual reviews and move entirely to compliance as code.
Meaning embedding transfer restrictions and AML rules directly into the smart contract standards themselves.
Precisely. If an asset is coded to only be held by a verified U.S. institution, the token itself will mechanically reject any transfer to an unauthorized wallet.
Natively and instantly.
Yep, without a human ever looking at it.
And finally, native interoperability.
The era of lock and mint bridges has to end. Assets must be able to move natively and securely across chains through universal messaging standards.
Eliminating those honeypots of locked collateral that plague the current ecosystem.
Exactly.
It goes right back to that email versus courier reality. You shouldn't have to think about the routing. An asset should move seamlessly and securely behind the scenes, just like hitting send on an email across different providers.
Right.
It shouldn't be freight, it should be data.
What's fascinating here is how we should interpret these massive structural breaking points.
What do you mean?
Well, it's easy to view the congestion, the fragmented liquidity, and the compliance gridlock as failures of the technology.
Yeah.
But analytically, they are the exact opposite.
There's signs of life.
Yes. They're undeniable, high-fidelity signals of extreme market demand. If institutional capital wasn't aggressively trying to push billions of dollars through these networks, the rails wouldn't be bending.
The friction is the ultimate proof of concept.
It is the ultimate global stress test.
Wow. Let's pull this all together. The undeniable reality we are watching unfold is that financial innovation sprints while infrastructure jogs.
Yeah.
We've dissected exactly why that is, how developers can architect brilliant new tokenized models in weeks, but the physical reality of zero-sum base layers, batch processing custodians, analog compliance frameworks, and highly vulnerable cross-chain bridges.
They take years to overhaul.
Years.
But historically, every major financial revolution hits a scalability wall. The system strains, it fractures, and then that exact breaking point becomes the mechanical blueprint for the next decade of development. The evolution toward parallel execution, zero-knowledge identity, and native interoperability isn't speculative. It is a mandatory reaction to the current bottlenecks.
And for you listening, this changes exactly how you should interpret the market.
Right.
The next time you see an explosive headline about a major institution launching a tokenized fund, or on the flip side, a massive network grinding to a halt during peak volatility, you aren't just absorbing the surface level noise anymore.
You understand the profound mechanical why beneath it all.
Exactly. You know exactly where the wooden tracks are splintering under the weight of the bullet train.
But there is a much larger, almost disruptive implication to all of this.
Oh.
If the infrastructure does evolve to seamlessly handle 100,000 transactions a second with automated, globally verifiable compliance and zero friction, what happens to the sovereign systems it was originally designed to integrate with?
Oh, wow.
If tokenized global liquidity eventually reaches a state where it moves natively, securely, and instantaneously across digital rails, we might see it entirely bypass central bank fiat infrastructure.
That's wow.
At that point, do national currencies and traditional monetary policy begin to lose their grip on the flow of global capital entirely?
That is a staggering thought to end on. We're so focused on upgrading the rails to work with the old world, we haven't fully grasped what happens when those rails become so efficient, they simply leave the old world behind. We've got a lot of building and potentially breaking left to do.
1, 2, 3, 4.
Yeah.